My name is Avi Schwab. I'm a senior engineer and project lead at Palantir.net. Palantir is a full-service Drupal agency, strategy, design, development. We're distributed, based out of Chicago, but we've got folks all over the country. So yeah, there's my infos. So today I'm going to walk you through a project that we did for the University of Michigan Health Systems. We're going to talk about the goals, how we thought about it and architected the framework that we built. So then we're going to go through a few of the pieces that I will discuss, and then we're going to talk about kind of how we got to where we are, and some lessons learned and where we're going. So first, some of our goals. Like I said, the University of Michigan Health System came to us. We had some other projects that we've done with them, but they needed a search application. Google has deprecated a few of its search apps, and so they wanted to restructure everything in a unified place. So they needed a simple way to store, retrieve, and parse their content. They've got a number of sites, some Drupal 7 sites with domain access, some Drupal 8 sites on a multi-site. They have some other sites that are outside of their Drupal ecosystem that they'll eventually want to all bring together in a unified search application. So they wanted this to be fast, new, speedy. It's a hospital, so people coming in want to get to their information fast. One of our goals in this project was to build something that we could reuse. I think in open source in general, we're always trying to abstract things as much as we can so that they're reusable, whether that's for a new client or to open source. And so those were our goals kind of coming into the project. Like I said, they also wanted it to be a drop-in replacement for their other search applications. They had some Google appliances. They were using Search API on a site. They were using Core Search. So really trying to bring all these things together. And so with all these goals, we kind of first did an assessment of where who their audience is and what that audience needs are. So we knew that, like I said, this is a health system. Their users may be in distress. They may have something going on where they need to find information fast, and they may not be in the best state. And again, people come to search when they can't find what they're looking for. So even if they don't have something going on, they're already in a place where they are lost quite often. Then what we assessed as our unknowns after we did our strategy work was we don't really know how visitors to a hospital site will want to have information presented to them. There's a lot of very context-specific data, and it's really hard to figure out this diverse population's needs. So that was kind of where we started from. So, just that was all we needed to make. Everybody wants search to be easy, and Google really does a good job of making it look easy, but it's not. So here's where we got to. So step back. In talking about this project, I was watching an episode of Shameless, and at a couple other places, this Ouroboros came up at the same time as we were working on this project. The Ouroboros is this ancient. It started as a alchemical symbol. This is from 3rd century Egypt. Anyway, it's a snake or a dragon. That's eating its own tail. So it's a symbol of life and the cycle of life and death. But in the kind of circuitous nature of everything. But as I saw this, I kind of started to put the pieces together of the similarities between this symbol and our application. So just to describe what's going on, so Drupal is the brains of the operation, is the head. We talk about headless. Drupal's the head. So Drupal is our primary data source, and it's where the content of the site lives in nodes, So it also controls our application. So we knew that the client had existing Drupal sites. They didn't want to get rid of those. They just wanted a drop-in replacement for a specific piece of functionality. So next, SOLR is the belly. So once Drupal eats the content, it all goes together in one place to be mixed up. Once we eat something, it all kind of looks the same. So SOLR takes the content, homogenizes it, and then that content goes to React. So React's the tail. It's fast. It moves around. It doesn't really move around. But it's able to display the content quickly and in a way that we can get it to a lot of different places fast. So we started with this kind of circle of our stack, but we actually have a bunch of sites, and so as I continue at extending the metaphor, we keep getting these sites that all have their bellies connected together, and then we get the Olympic rings. But it really is, when we put it all together, we have many Drupal sites, a single SOLR instance that hosts content that's sourced from all of these different sites, homogenized, and then served out into these independent SOLR React applications. So here's what it looks like in practice. This is just some screenshots, just showing that we're presenting this thing in a unified way across lots of different sites. So this is the D7 site. This is one of the Drupal 8 sites. This is another Drupal 8 site on the same multi-site core. This is another one of the Drupal 7 domain access sites. You can see, they've all got different branding. They've got different menu structures, and they even have different styling in the application. But they're all rendering the same content in the same basic way. So I think that's pretty powerful. So now we're going to start into some of the details of the application. So as I said, Drupal is the head. And we started with a basic Search API SOLR implementation. Search API SOLR is really powerful. We've used Search API on a lot of different sites, and SOLR is really great at being a little bit more powerful than Drupal's core search. So our setup here is pretty straightforward. It's just a SOLR server with a single index, and so every site in our multi-site is talking to this one index, and I'll get into that more in a few. But where the magic happens is when we set up the fields in Search API. So one of the requirements for being able to get data out into our React application is we need it to be consistent. We need it to be homogeneous. Drupal, when you're building a regular Search API view, has the ability to query nodes. And so Drupal, when you're building a standard search view in Drupal, you can get whatever you want out. You can render view modes. You can do whatever you want with that content. But now our search application is totally separate from our Drupal application. So we needed a way make sure the content coming to SOLR was consistent. So we built these 3 types of custom search API processors that expose some new fields that we can do some pretty fun stuff with. So we've got one called federated field, one called terms, and one for the site name. And I'll talk a little bit about each one. So the basic field, you'll see a few names here. We're in the process of open sourcing all of this stuff. We're rejiggering some of the way it works and renaming things. It started as federated. It's going to be mapped. So that's why it's got a couple different names right now. But the basic idea here, if you've ever used meta tag module, where you can you can set tokenized values for all of the stuff you spit out into meta tags. My idea was basically to build that functionality for Search API SOLR. So here we've got the edit form for this field that I've called federated type. So this is a content type. One of the things that we saw when we did our strategy work is every Drupal site had, from 4 to a dozen different content types in Drupal, many of which didn't really have names that made sense to expose to users. So a blog post, a news item, an article, those all are basically the same thing. So we wanted to aggregate those into more user-friendly names. So this is an example of just mapping data from each of our bundles, our content types, to a straight text field. So we can say, basic page is actually the general content type, and we're filing videos under blog article. So this allows us to make the data a little more user-friendly. This is an example of the date field. So we're able, this is pretty straightforward, but this is an example of how we can use tokens in the field. So if an article had a separate publish date, whereas most of the rest of the content has standard created date, we can use different tokens to expose that data into the same field in SOLR. If you were to do this with a standard Search API fields, you would get this data into a bunch of different fields in your SOLR index. So the idea here is we want all of this data to be in the same place in the SOLR index. This is an example of an image field. So here, images often exist in a lot of different places in Drupal. And so this, we're bringing image and media image, and we're rendering out an image style. For a video, we're actually pulling a video thumbnail. So this is I think really even more powerful. Again, we're able to homogenize a lot of disparate data into one field. And pages don't have any image, so we're just leaving that out. So next up, we've got site name. Drupal site names are often not super user friendly. So you might have the actual name and a pipe and something else. There's a lot of different ways. This red box you can see is what the Drupal site name is actually set to, and so that's great for being in your title bar. But again, when we're building kind of filter facet things from this data, we want it to be a little more consistent. So the site name field, we're able to have the users enter what they want the site name to be. This also could let you aggregate data, basically make data from a couple different sites look like it's coming from the same site. So if you had a couple multi-sites that weren't really important to show that they were kind of differentiated, you could just set the site name the same there. We're also using this, like I said, for a specialized filter in the application. So we broke out the site name into its own field instead of it being part of the regular fields, just so we can make sure that it was special. Also on the right side here, so we built this all for Drupal 8, but we had a bunch of Drupal 7 sites. So this is a screenshot of the Drupal 7 config, which also supports domain access. So like I said, domain access lets you host a lot of different sites from a single core, and so we're able to set this stuff not only per bundle but also per domain access site. So finally, we got to terms. We did an assessment of the vocabularies in these sites and found that the taxonomy terms were hugely disparate across the sites. There were thousands of terms, everything from very general to very specific diseases that the hospital worked on. And again, those are not particularly things that we wanted to deal with displaying or expose to the users. Those are, if they're digging into something, they may need those. But if they're searching for a specific, if they're searching for something, we wanted our filters to be a little more generalized. We also needed the ability to support mapping between these terms. So there may be, a dozen taxonomy terms across the sites that all mean roughly the same thing. We want to be able to aggregate those. So we needed this many-to-many mapping. We needed it to be somehow manageable for content editors. We needed, we also needed it to be maintainable. And so we came to this solution that we're able to aggregate taxonomy terms, support an arbitrary hierarchy, so that the maintainers of this application can build out a new hierarchy of search terms for this application with basically unlimited flexibility. So it starts with a field in Search API that doesn't have any config. It just gives some instructions that turning this field on is going to expose a new field in your taxonomies, and you need to go set that up. So this adds, like I said, a new field called federated terms, and this is really just a multi-valued text field that gets added to taxonomy terms. So on every taxonomy term, in the vocabularies that this field is added to, you get an extra field here that says, gives some instructions and tells the user what to put in. So, for example, we could have condition diabetes. So this lets us, like I said, aggregate a lot of disparate terms into something that's a lot more user-friendly. And finally, we bring this back into the search application right here. So I'm mixing some health data with our demo application. So so we've got some hospital content and some umami content here. So this ingredients dropdown is one of our arbitrary categories that we built and assigned these labels to taxonomy terms in the site. And so we're mapping these new terms, carrots and mushrooms and ingredients, from their corresponding taxonomy terms. So there's a lot there. This is the most complicated piece of functionality that we had to deal with. Taxonomy is when you get into the both the data and the strategy of architecting a system for organizing things. This is a whole field of research in and of itself. So it took us a while to get to this solution. And it does take a little bit of work from the content manager's side to really think about how they want these filters to display. And that's work. Because maintaining content and providing a good user experience is a lot of work. But I think this is a pretty solid solution to making a flexible interface. So next up, we're going to get into SOLR. So like I said, we built all of this in Drupal to send this data to SOLR, because SOLR is pretty great. It's if you're not familiar, SOLR is a CMS agnostic search application, and really SOLR doesn't care. SOLR takes things from wherever sends it data, and it dumps it out. It's flat and pretty homogeneous. So I spent a lot of time. I'd done work in SOLR before, but never really delved too deep into the system. So I'm going to show you a little bit about what helped me there. Like I said, I've always done SOLR from the Drupal side, and so I always had Drupal views to help me do that. So now we were kind of totally separated from Drupal. I needed to figure out what was going on. The SOLR admin query builder is actually really great. It's got every possible thing that you can put into a SOLR query in this nice GUI. You can test out what's going on and see the data. So this is super friendly. SOLR has always been a black box to me. It's just like there's a lot of stuff going on. I actually started reading some of the documentation about how rankings work and how boosts work, and there's more math in there than I could deal with, having done a significant amount of math in college. So you never really know how SOLR. I never really know how SOLR is actually going to work, but this at least helps me to see what's going to happen. And like I said, SOLR spits out JSON, and so the whole point here is that we've got a really fast query, a really fast response to our search queries. So we're able to send the query, receive some JSON back from SOLR, and dump that into our application. So as I alluded to before, because we're abstracting this data from Drupal, we needed to set a schema that our data would abide by. We've got a relatively fixed way of displaying our data, and we want to, our React application doesn't know anything about the source data, and it only knows to display the fields we tell it. So part of the work that we did was documenting the schema as it should go to React. So theoretically, somebody could develop a plugin for WordPress or a static site generator or anything that would send data to SOLR, and as long as it abided by the schema, the React application would be able to consume it and display it. SOLR can also contain extra fields if you wanted to display data in Drupal using Drupal views, maybe as a fallback for the application. You could still send that data to SOLR. It doesn't get in the way of the rest of the things. So you can have all of these things commingled in SOLR. But really, this was a pretty, basically I just went through some search applications, went to Google, figured out all of the pieces that built out the display, and kind of put those things together. Finally, the tail of our application, as I've said, is React. So I was going to say at the beginning, both my mom and my cousin read my session proposal for this, and they're like, "We don't know what any of these words mean." And so I had dinner last night with my cousin, and I described this project to him as the software I built my career on, the software that I've worked with a few times, and a thing I didn't know anything about that I took and put all together to make a thing out of. So that's React. I hadn't worked with React before. I have been a full stack developer, but never really delved into the JavaScript side. It was mostly new to our agency too. But luckily there's a great community out there and a lot of resources. So we kind of dove right in. So the short pitch for React, which most of you probably don't need, but it's a library for creating consistent, efficient user interfaces. It constructs components out of external data, which calls props, and internal data, which is state, and it renders that to make an application. Like I said, I came to this mostly from the engineering side, and I figured, it's not too complicated. It's a JavaScript library. What do you do to install a JavaScript library? You run npm install, and then the library, and then magic happens, and then everything works. It's wonderful. That's about how it works, right? Well, it turns out I wasn't too far away. I looked around and found a library for querying SOLR from React and building modular components on top of that. So that was pretty wonderful. We were able to get a lot of the way towards having our application, on somebody else's work. So that obviously wasn't the whole story. This is what this library looks like when it's rendered out. It's functional. It's got a lot of components there, but we needed to extend it a little ways to get the really robust search experience that our users wanted, that our client wanted. Like I said, this library exposed a number of components that we could theme as we needed. So we had this framework for our application already set, and we had a prototype. Our designers built this prototype search application. It's got filters, it's got a search box, it's got all of the pieces that you would expect in search. So we started taking the pieces and mapping the existing components in the application to the things that we needed to build. So just kind of making all these connections, we were able to build, to extend each of these components and make them do the things that we needed them to do. Hey, this is actually not too bad. So I chunked up some code. There are a lot of code standard violations on this page. But this is an example of one of the components that we built. So just to take you through, this is our results display. So this is, again, a standard React component. So it imports some libraries. Then we've got some custom functions here that are doing some work, formatting our date and concatenating some values. And then the meat here is in our render function. So the render is where we're taking our document and the highlighted results. We're building out the markup that we need. Finally, at the end, we're declaring how React can see this, so the prop types that it needs and what it exports. So like I said, this was all pretty new to me. We had another developer who came onto the project who also had some experience with React. But it was really interesting figuring out how these things work together. Mapping my knowledge of PHP and front-end stuff to the JavaScript. It was a really interesting process, but so once we have all these components, we just create React app to build this with its dependencies, pack all that together into consumable CSS and JavaScript, and then send that off to our host site. So, looping back around, the teeth of the head, if you will. So back in Drupal, we're serving the React app from Drupal. And so part of our module creates a route, but it also adds some config, which we're able to pass to the React application. So in here, we're setting the path that the application will live at. We're able to select the search index that the application uses. So if a site is using SOLR for a bunch of different purposes, we can actually choose the correct one. Our search application, Umish already had an existing agreement with Search Stacks, which is like a SOLR as a service provider. They were awesome, highly recommend. But they had their SOLR under HTTP basic auth, so we had to allow for username or password to be passed in. Some more stuff, setting the site name, results text, the number of search results, pager stuff. So this is all things, config that we're setting in Drupal that's passed as props into the React application, which is pretty cool. And then essentially rendering the application, just like any other JavaScript app. We've got some stuff that builds our config as a little JSON string, but essentially we've got a template that puts a div on the page. In our libraries, we're calling the CSS and JavaScript that we need here. But really, this just adds the hook and some config and a data attribute, and React takes all that, hooks on to all that, and builds our application. So that's a lot of things. Kind of tying it all together. As I talked about, there are a lot of pieces to this application, and I was learning React as we went along. We were kind of we started from a couple pieces, and we're slowly kind of figuring out how to build this. So we figured out pretty early on that putting lots of pieces together is really hard. Jess put these slides together when we were kind of trying to wrap our heads around what was going on. And so this is the dependency architecture for our application. So it started out, we were building the React in our style guide, just a static, like statically generated style guide. And because I didn't know how all these pieces were going to fit together, so we were just kind of building the JavaScript right into that. As soon as we started putting Drupal into the mix, then we had a Drupal module. We had the base React application, our fork of the React application, our customizations from the React application, and then we had our style guide and a bunch of Drupal sites that needed to consume all of that. So we pretty quickly had to get to a point where we broke all of these pieces out into individual repos, and the almost final place, and I say almost final, where we're in the process of getting these things ready to open up, and we're doing one more separating the Search API processor, the field processors, from the rest of the application, so that if you needed to, you could use those processors in a totally different app if you wanted to use that field functionality somewhere else. But so we have our Search API Federated SOLR module that kind of ties everything together. We had our static style guide that still consumed the things. It's hard to see the dotted lines here. But each of these requires these different libraries. So the scaffolding, our fork of it, and then the federated search React app are all bundled up by NPM or by all of the task runners, and then sucked into Drupal as libraries. there's a lot there. These will go up. But the gist of all of this is, decoupled applications are complicated, as I've heard in almost every session today. We're adding more tech debt every time we add another layer of complexity, and so we really need to make sure that we're identifying that for our clients, and that we're making sure we mitigate that when possible. Some more lessons learned here. Like I said, it's hard to build an extensible, content CMS agnostic, flexible product in a standard project timeline. We had to go through a lot of complicated decision making to figure out how to build a lot of these pieces, and every layer of complexity made that harder. So again, search is hard. SOLR is kind of a black box. There's a lot of complexity to just figuring out, how your results should be ordered, how the data should come in. Like, do we need to boost things? These are all questions that are going to come up at some point in the process, and figuring out how to deal with those as early in the process as you can is really important. Building fallbacks, requires some hard decisions. If we're gonna build a fallback for this, do we sacrifice our display? Do we sacrifice our content? Like, how do we build something that still works and is still accessible, but gets us part of the way there? Domain access adds complication to everything. Questions like, what if a piece of content is published on multiple sites and one of the sites deletes it, or it's unpublished from one place but not the other? If it's in multiple places and it's only listed once, where does the link go? These are questions we're still trying to solve. So deploying this to single sites is pretty solid, but the domain access stuff, luckily we've got a pro on the team who's able to help us out with some of that work. And finally, like I said, we are planning on open sourcing all of this work. We were hoping to get it done by this week, but didn't quite get there. So coming soon to GitHub and D.O near you, we'll have the Search API Federated SOLR application, which I said is the kind of umbrella module that packs all these things up together. Search API field map, which is the custom processors, which will be able to be used independently. And then the Federated Search React application, which again could be built as a standalone application, not necessarily in Drupal. We've also got a demo site that I built, that our team built using the Umami distro. So as we were finishing this up, I was like, I really need a place to show this off that isn't a giant multi-site with a ton of clients' information. So having Umami was great because we had content already there. So all I needed to do is get our module and enable it and do some really light theming. And we've got that up. I can show it in just a sec. And again, if you'd like to, if this sounds like something that'd be interesting to you or a client, let us know. We would love to continue building this application, extend it, and refine it to help other folks out. So that's it. Jess Constantine, she was my co-presenter for this. She developed a lot of the application. She wasn't able to make it today, but she helped out with a lot of the pieces of this. That's our information. Before we do Q&A, I'll do a quick demo. So like I said, this is core Drupal with Umami turned on and our module, and like 20 lines of CSS. So I made an awesome, totally unthemed search box here. And we can search for Umami. And this is the application. So we've got our little filters on the side. Again, when you bring multiple sites into this, that's where a lot of the power comes from. But this kind of demos the functionality. So we've got filters. This is our taxonomy terms, and this is our display. So, it looks like search. It's React. It's quick. It does what it's supposed to do. We've wired it up to so this is a block that hooks into the application. That's also part of the module. So that's it. My last pitch. In addition to my work at Palantir, I'm a co-organizer of MidCamp. MidCamp 2019 is March 20 through 23rd, 2019 in Chicago. We're moving back to a Wednesday through Saturday format. So sessions will be Thursday, Friday, with some summits on Wednesday and sprints, community day stuff on Saturday. Submit your session soon, probably in the fall. But we'd love to have some decoupled stuff here. So, got maybe a couple minutes. Any questions? Yeah, Matt.
So React is querying SOLR directly and not like a proxy through Drupal.
Correct. Yeah. So the question was, is React querying SOLR directly? So the only communication between React and Drupal is that those couple pieces of config that get spit out as JSON, as a little JSON object into the div. Yep.
How do you lock down that? How do you lock the access to the SOLR?
How do we lock down the access to SOLR?
Yeah, because anyone can do like I don't know. Whatever carries he wants.
Yeah. So the like you saw, there's a HTTP auth in front of the SOLR. Search stacks. The SOLR provider provides some permissions around that. So we have a read-only HTTP auth account that the application sees. It's not secure. Like it'd be relatively trivial for somebody to get those credentials because it's a front-end application. But like I said, the hosting provider provides that level of access. So somebody could theoretically get those permissions, those credentials, but they'd still only be able to do to query to have read access to SOLR. So yeah, I mean we can't lock it down completely, but the data is already online. It's already public, so it's what we could do. Yeah.
Sorry.
Yeah, go ahead.
So at the end, it's going to render the HTML generated by the Drupal, right? That is persisted on the SOLR. Like the item, the element,
yeah,
is mounted in Drupal, right? The HTML.
Yeah. So
the link is actually the middle thing.
Yeah. So the question was, is the HTML rendered in Drupal? This is actually it's rendered client side. Is that what you're asking?
No,
so
only the item, the result item.
Yeah, the results, so everything in the application, everything below the breadcrumbs here basically is from React.
Okay.
Yeah. So each of these filters is from React. So we have three kind of special filters. So we've got the date. This is using Airbnb's date picker, which is pretty great. The site name, which, like I said, we've got that broken out as a special field so that we can filter through specific sites. You can also set the application to default to searching on the site that you're on, which is pretty cool. And then below these are all of our arbitrary term filters. The search term, the current results, the sort, all of this stuff is coming from React. Yeah, do we end at 3:30? Go ahead, Matt.
Your fork of the React Solar thing, is that public or is that still like a private fork?
It will be public momentarily. The rest of the team is working on cleaning some of this stuff up. We wanted to nail down a couple pieces and make sure things were ready. So yeah, it's coming soon.
What happens when you start indexing non-Drupal sites in here?
Sure.
Is that something that is going to happen anytime soon with this project?
That's up to the client to implement. We're not part of that. But as long as the content respects the schema that we've defined, the application will be able to render it. So in that schema, is the site name, the URL, the title, description, the tags, the image, everything that's needed is defined in that schema. So you could send stuff to Solar by writing it by hand, hand-coded XML like talked about this morning, and that would be totally fine as long as it had the data that we needed.
I got a quick question.
Yeah, we've got 2 more minutes.
Last one.
Yeah, go ahead.
It's just a basic caching question. Have you built in any caching into the React app side of the equation for like when each search request gets made, caching each request?
Sure. So the question was, have we built any caching into the React side of the application? We have not. That'd be great to do, but like I said, Search Stacks it's running Solar as a service. They do that for their jobs.
It's good.
Yeah, no, and it is, and I've had great experiences with them. They were really helpful troubleshooting CORS stuff. We had to deal with CORS when we were setting all this up because we had a lot of domains querying the same server. That sucked. It was pretty complicated. But I got a person from their support team. We hashed it out on a couple Zoom calls and made it all work. Yeah. Cool. All right. Like I said, I'm Avi. If you have any questions, I'll be around. You can also contact us at palantir.net if you would like to work more together. Thanks, everybody.